All right. So this is kind of a fun section because it looks really cool on Desmos and it's pretty easy to do. So we like those two things, right? It looks cool and it's easy to do. We'll take it. All right. So what we're talking about is we're talking about systems of linear equations, right? So we 3-1, we basically graphed two lines and figured out where they intersected at, and that was the value, the ordered pair value that makes both of them true. And then in 3-2, which is just a lot of math, we did the same thing, but we did that by substituting one equation into the other or eliminating a variable and solving for one x and then figuring out the y or finding the y and the x. So 3-3 is a little different because we don't just have equations, we have inequalities. All right, so an inequality is just like an equation, right? Except it's all the values that are either greater than or less than or equal to a specific value. So when we're solving a system of inequalities, we're not necessarily just going to get one answer. We're going to kind of get a range on a graph of possible solutions. So really, when you're looking for the solution to an inequality, you're talking about the area on the graph that holds true for both of them. Okay, so first example, we have two inequalities here. We have y is less than or equal to 3x minus 2, and y is greater than negative x plus y. All right, so this is a pretty easy one. I wish my graph was a little bigger. Like, let's see if I can get both of them on the screen at the same time. Zoom in a little. There we go. Except my graph's going to be really small. All right, print screen. I know what we'll do. We'll open this in Paint. We'll make it bigger. We'll steal one of these graphs and copy it and open it up. We're going to make it bigger. So we can, okay, well, close enough here. All right, so we have these two equations. I'm going to start, what I'm going to do is I'm going to go ahead and I'm going to graph my first equation. I'm going to graph the first equation in red. All right, so since you're my y-intercept person, right, I have, basically when I graph it, I'm going to graph the line and then I'm going to figure out where I put my shading, okay? So where's the y-intercept? -2, right? You're my y-intercept person. All right. And then the slope, yeah, the slope is 3. So my slope is going to be rise 3, run 1. There's a tiny little point there. Rise 3, run 1. Rise 3, run 1. Okay, that's my line. All right. It is y is less than or equal to. So because of that, I can draw a solid line, right? Because if it was a, yeah, because it's equals to, I get to draw a solid line, not a dashed line. All right, so that's my line. I get to keep going. And then I've got to figure out which side do I shade. All right, so y is less than or equal to 3x minus 2. I have a feeling it's going to be, which side? Well, I know. So if I stick 0, 0 in, then I can figure out which side I shade, right? So if I put 0 in here, I get -2 is greater than 0, which is not true. So that doesn't work. So if I put in over here, x equals 10, y equals 0, then that's true. So I know that this right side over here gets shaded in, just for my first equation. All right. And then this line keeps going, and it's beautiful. Okay, so that's my first line. My second line is y is greater than -x plus 4. Okay, so I'm going to graph this one in, I don't know, green. We'll go Christmas. Okay, y-intercept is at 4, right? You're forever stuck with that, Connor. Sorry. All right. All right. My slope is -1. So I go down -1 over +1, down, over, down, over, down, over. Okay. We've got these tiny little dots going on. Now, what's going on with this line is that when I draw it, I'm going to have to draw it by hand because this line is dashed because I don't have the greater than or equal, I just have the greater than sign. So it's actually not along that line. All right. Again, with the shading, I look at 0, 0. If I plug that in, 0 is greater than 4. That is not true. So up here is where I would shade in. Okay. So now what does that mean for my actual solution to my equation? So when I actually want to find out which values make both true, I'm looking where they intersect. All right, so my graph of where they intersect is going to be my black line here, okay? So it's anything along here, that's true, okay? And then down here I have a dashed line. And then it's basically anything that's left, that's basically overlapped, that becomes my solution. So anything in the black area is a solution to my two equations. To my two basically equations. That is a beautiful graph. I know. It's gorgeous. So that basically means I could pick anything. So I can see right here 10, 0 appears in both, right? So I'm just picking a random point. 10, 0 appears in both. So this should work for both my equations. So 0, my first equation is 0 is less than or equal to 3 times 10 times 10 minus 2. So 0 is definitely less than 28. So that works for that one. All right, and then my other point is 10 is greater than 0 plus 4. Excuse me. So that is also true. 10 is greater than 4. Grab a quick drink. Okay, now, if you don't want this graph as beautiful as the one I just did, hold on just a second. All right, if you don't want this beautiful graph, then we can switch over to Desmos and see what we get there. So let me make it a little smaller because I don't remember what the numbers were. Y is less than, no, make sure you type it in right, less than or equal to 3x minus 2. Okay, oh man, it graphed it green. This was my red graph. I need a different color, Desmos. It's driving me crazy. There we go. That's close enough to red. So there's our red graph. And then our green graph is, it was playing tricks on us. It knew we'd graphed it the other color. Okay. We've got our, they're just flip-flopped in the way they're written here. All right, so we have our red graph and our green graph. And so then any value that overlaps the shading, so basically we could pick anything out here and it would be a solution to both of these equations. All right, so, and we can also pick values that are along this line. That's okay, because it's a solid line. We cannot pick values that are along this line. So it's the values that get really, really close to this dashed line, but they can't quite get there. So the solution would basically be everything that's in this shaded area. So that's it. That's all you do. You graph them and you figure out where the shades overlap. All right, it's pretty easy, right? So number 2, we're just going to do it by, I'm just going to copy number. We've got x plus y is greater than -3. So this is the same way. let's see. We've got x plus y is greater than -3. And we have -6x plus y is less than 1. All right. So let's make this a little bigger so we can actually see it. All right, so this is very similar. That's why I didn't, sit there and graph it by hand. But we have these two equations. This one's slightly different because you don't have a hard border on either side. They're both can get close to this line, but it's just going to be this shaded area over here. All right. Let's see. We've got another. Let's see if we can do this one kind of by hand. So this is kind of going to make a pretty one for us. Let me copy and paste it and pull it out in Paint. Okay. Make that bigger and get a graph. I hear you. I hear you. Okay, make the graph a little bigger. All right, so the first one's easy, right? Y is less than -2. All right, so that's pretty easy because, oh, I can't draw that though. Y is less than -2, so let's draw this in blue. So it'll be pretty. Here is -2 is down here, right? And it is, that's very counterproductive. We're drawing little lines here. We got a dashed line across here, right? And y is all the values that are less than -2. Oh, I feel like I could fill this all in with color. Let's see. Let's get fancy with the paint colors here. All right, so it's all these values down here. That did not work. That's what I get for, there we go. All these values down here. Wow, I really got that out. All right, so now we have an absolute value function. So remember, absolute value functions are the ones that are like the triangle, right? The standard absolute value function goes, comes in this way and out this way, and it follows the line y equals x. So it's like 1 to 1. But we have a couple things going on with this one. So we have inside the absolute value, so it's inside the function, we're adding 2. So when you add 2 inside the function, that actually shifts your graph to the left by 2. Okay, so this one will graph in, not that. This one will graph in green. So it's going to shift our graph to the left by 2 because we're adding 2 inside the function. So we have a point right there. And then the other thing that we have is that it's negative. So because it's negative, it's getting directed across the x-axis. All right. So, and this is a y is less than or equal to situation. So we actually get to draw our solid line here. Now I actually want my line tool. Here we go. So we get a line that goes this way and a line that goes this way for our absolute value function. All right, so now what part of this triangle do I shade? Let's see. 0, 0, our good friend 0, 0. So I have y, if x is 0, 0 plus 2 is 2. 2 is greater than 0. So it's all of this, sorry. No, I did that wrong. Say something felt wrong about that. So if I put in 0, 0, right? it's 0 plus 2, and then it's negative 2. I'm like, I forgot my negative sign. So negative 2 is not bigger than 0. So that means that all of this inside here needs to be shaded in. If I can get my brushes to work, all this over here needs to be shaded in. This is just a beautiful drawing, Connor. You're thinking we should just use Desmos, right? Just beautiful. All right, so then when I go to overlap the two, you kind of have to like think in your brain. Okay, the overlap part is along here, and then it's dashed along here, and then it's along here. So my overlapped values are in this kind of cutoff triangle. So anything that's up in here, what is that at? Like -2, -1 won't work for both. Yeah, that won't work for both of my inequalities. But anything that's down in this black area should work for both my inequalities. So then if I go to Desmos, it's going to look much prettier than what I just did. So we had y, oh, I forget my equations. Y is greater than, did I graph that wrong? Connor, I graphed it wrong. Y is greater than -2. I had it going the wrong way. Well, what I did, I was just testing you out totally, is this. It's what I graphed. I think, let me double check my work. Y is or equal to negative. I don't know. I need to go back and look. I need to go back and look. This is what we did. Y, this is what we graphed, is y is less than -2. Let's see what I did over here. Well, no, because I read it wrong. Oh, no, you're right. No, I totally graphed it wrong because it was y is greater than -2, and I went for y is less than -2. So my bad, I graphed the blue line wrong. I went on the wrong side of the graph, right? Because y is greater than -2. So that makes an even prettier graph, though, than what I had, because basically what that does, this was my original problem. Right here. That was my original problem. I would have checked my work carefully. All right, so then I'm just going to steal this from Desmos and open it in Paint. So my values that would be true for both of these would be basically my triangle. So the only values that are true are everything that's in my triangle. It can be along this solid line, but it can't be on the dashed line at the bottom. That's much prettier than what I did. Just the tip of the mountain, right? All right. So always check your work. All right, so these last few, I'm just going to basically throw into Desmos, and we can kind of look at them because I did make myself practice so that I get them right. I'm just kidding. All right, so we have x is greater than or equal to 8. X is greater than or equal to 8. So before you even do it, so this is what I would recommend doing. I think you can use Desmos. It'll be a super easy section, right? But I would recommend kind of like testing yourself as you do it because it's a good way to practice graphing. So we have x is greater than or equal to 8. X is greater than or equal to, before I even put it in, I'm going to turn it off. I'm not looking. Okay. X is greater than or equal to 8. So I know that because this is an x value, it's going to go vertically, right? And I know that x is greater than or equal to 8. And I'm actually going to read that right now. So it means it's going to be all these values over here with a vertical line going this way that's greater than that. All right, so here we go. There's our x is greater than or equal to 8. All right, I also have a value where y is less than or equal to -1. So this must have been what I was graphing before, totally, right, Connor? Y is less than or equal to -1. So I know that this is going to be a line at -1 along here. If I wish I could graph along here. I know that this is going to be a line along here, and y is less than or equal to -1 is going to be down here. So y is less than -1. Was it an equal to? I can't remember. Oh, and equal to. Okay. All right. So already we've basically cut our graph out, and the only values that we can have are down here in this area. All right. We've cut out all the rest of our graph. So basically anything that's kind of in this really dark area that starts at 8, -1, that's where we can have values. All right. And then we have a line that is y is less than -2x minus 4. Y is less than -2x minus 4. Okay. So now we've got all these things going on. We got to figure out where all three of these intersect. So all three of these intersect way down here at 8, -20. So if I wanted to show all of the values that are true for all three of these equations, I would say that they are here and along here and everything in this shaded area. Okay. So if I picked a value that's along here, like this looks like right here is in there, right? This is when x equals 10, y equals -40. All right, so if I go back to my equations, does it make all of these true? Is x greater than or equal to 8? Yes, x is 10, which is bigger than 8. Is y less than -1? Well, y is -40, so it's definitely not less than -1. And then if I plug in my numbers here, so -2 times 10 is -20, minus 4 is -24. -24 is bigger than -40. So somehow we've managed to find this little slice of number line that is true for all three. Okay. And then the last one I think is just fun to graph. This one's kind of a fun one. So we actually have 4 equations that we're going to see where do all 4 of them have values that are true. If I can get Desmos up here. So I have x plus y is less than 5. I have x plus y is greater than -5. I have x minus y is less than 4. And I have x minus y is greater than -2. Okay, let's see what happens. We might have to like turn one of these on at a time to kind of figure it out. Okay, so first I have the blue equation, right? X plus y is less than 5. So it's all the values that are shaded in blue over here. Can't be the ones along the line. Then I have my green graph that I overlay over the top. X plus y is greater than -5. So now I just have this band here in the middle that is true for both my values. Then I add my third equation. Okay, so now I have x minus y is less than 4. So I have this little rectangle going up this way. And then I have a fourth equation, x minus y is less than 2. So when I get down to it, I'll zoom in a little bit here. I basically have this rectangle here that shows all of the values that make all of these true. It can't be anything that's along these lines, but it can be anything that's inside here. And it has my favorite coordinate, 0, 0, right? 0, 0 is true for all of these. 0 plus 0 is less than 5. 0 plus 0 is greater than negative 5. 0 minus 0 is less than 4. And 0 minus 0 is greater than negative 2. So when I would draw this out, I would basically draw this, and I would show this rectangle as the values that make all 4 of these inequalities true. Cool? Awesome. So that's it. That's what I wanted to go over today. On Monday, we're going to do equations with 3 variables. So that's a lot of math. So don't save 3, 2, and 3, 4 to do at the same time, for sure. All right. Have a great day, Connor. Thanks for joining. All right. Thanks. Bye.